So I'm going to do this. I'm going to cheat a little bit. Let's see, come over a little bit. Okay. Elimination seeks to add the two equations with the intention of causing one of the variables to cancel. Not all equations that you're given are going to be set up immediately where you can add them together and get rid of one of the variables. So sometimes this step may require you may need to use a multiplication step first. So how do I know when it's a good idea and when it's not a good idea? Look at your equations. If your intention is to get a variable to cancel, then this is the best case scenario that you could see. Having one variable already have opposite coefficients. Doesn't have to be the y variable, could be the x variable. Doesn't have to be the first one, then it could be the second one. You could have your negatives over here and not have these be different in the problem. The key is I want to be able to think of this like a long column addition problem, where when I add these things together, so some things drop out in the problem. Very visual. So this would be a perfect scenario. If I add it together as these are right now, this particular system here is ready to go right now without any problems whatsoever. When I add them together, what happens? The y's cancel out, so I'm left with a 6x. Y's go away. That was nice. And on the other side of my problem, I come up with a 12. If 6x is equal to 12, then doesn't it follow that x has to be a value of 2? So you have half of your answer pretty quickly. To complete the solution, we go back and substitute again. Substitutes the value of the variable that you just found into one of the two equations that you were given. That means either you're going to select 2x plus y equals 8, or you're going to select 4x minus y equals 4 to be able to find the second part of the answer, to find the other variable value. You don't always get x first, you might get y first, you got to go back and find x. So it doesn't make a difference, you're not done with your solution until you have something for the x hand and something for the y hand. Doesn't make a difference which equation you pick. Some of the equations that might have nicer set of numbers, nicer sets of signs, and might be a little bit more attractive. So here, maybe this equation is a little bit more attractive because I don't have any negative signs to worry about and any potential simple mistakes in the problem. So 2 times the x value plus an unknown y value equals 8 also sets up a relatively simple equation to be able to solve. 4 plus y is equal to 8, and I'm assuming that you would want to subtract 4 from both sides of the problem there, coming up with a y value being equal to now 4. So you have a potential solution in your problem that says x is 2 and y is a value of 4 that you think is good, but you can always verify it by checking. And checking would mean you take it back to the original equations and find out if it satisfies both of them at the same time, just like the very first thing that they solved us in the exercise. Just to show you that it doesn't make a difference, if you went to the second equation and you dropped the 2 in there, 4 times that value of 2 minus the value of x that we brought, of y that we brought 4, should give us a value of 4. And we know that 8 minus 4 is also equal to, wait a minute, I'm checking that problem, not solving it. If I'm trying to find y, I take the value over here. So I now have a minus y is equal to 4. I have 8 minus y is equal to 4. I would once again assume that you would want to bring the 8 to the other side of the problem by doing a minus 8, which means that you would come up with a minus y being equal to a minus 4. And wouldn't that then force you to go through the step of stripping off the negative coefficient of the problem? Wouldn't that leave you with the value of y equal 4? And isn't that the same value you had there? So would it really make a difference which equation you picked? Not at all. Okay? So one way or the other, you've got to be able to demystify that. Now we've seen the simple problems that were ready to go to begin with. They aren't always going to be ready to go. So you might see problems that get a little bit more challenging, such as